now to talk about artificial intelligence. So let me introduce you to Lukas. Lukas, hi.
Hi, George.
So when we look at artificial intelligence, one of the great things I think that we have here at Arrow is that we cover the entire line card from the smallest microcontroller, indeed from AI inside embedded sensors, right the way through to high-end solutions. Could you please just walk me through some of the demos that we have today?
Sure. As you said, we have demos coming from the tiniest of devices, running for anomaly detection using sound data and time series-based data through computer vision and object detection running on tiny microcontrollers, often using neural accelerators, but also using the Cortex-M compute capabilities to run those sophisticated models. Going from that, we have more sophisticated vision-based transformers running on microprocessors. We have our segmentation models going to a full-blown multimodal pipeline that is able to understand human prompts to generate results.
Thanks so much, Lukas. Now, one of the things I often find when we first talk to customers about AI is they're concerned about the initial complexity, and they maybe don't have people on their staff to get up to speed and develop their own AI models. What would you recommend they do?
So this is something that we as Arrow and our partners can help our customers with. We have a lot of experience in helping to translate these use cases and requirements that the customer may have, and to guide them and teach them on how to use AI for their engineering projects and to solve their needs. And you can either use Arrow Engineering Services from Arrow Engineering Solution Center or eInfochips to help you and your customers to jumpstart the project, or you can work with Edge Impulse, which is a partner of Arrow's that's now part of Qualcomm, to help to get started with AI as well. And in both those cases, you can get help to collect a data set, translate the use case into specific project requirements, train the model, analyze different types of models on performance, memory footprint, to help you to select the right device for your system.
Thanks so much. And I guess here what we're seeing is Edge Impulse running on Qualcomm's Dragonwing RB3 dev kit. And what is it exactly that this screen's showing us, Lukas?
So this screen is showing us the accuracy of the model, and it's showing us what we call the confusion matrix. So for an image classification model, it would tell you how certain the model is of the correct class, which is this diagonal that you see, versus different classes. So it's showing you the results of a training, because you can use Edge Impulse to not only deploy a model, but also to train your model, and even to use the tool to label a data set. So it's a complete pipeline, complete solution that you can use from the start of a project to get a complete system or firmware that you can run and deploy on devices. And more than that, you can actually deploy this firmware on the cloud to get different evaluation results on different types of hardware, Cortex-Ms and microprocessors like the Dragonwing, to understand the needs of your system before actually deploying it on a real device. So you can use the cloud to actually, and the devices connecting the cloud, to get the actual performance results as well.
Yeah, that was fabulous. When we looked at that earlier, what we did was took this model and we connected to Qualcomm's AI Hub to run the model on real hardware that sat somewhere in San Diego and come back with the real results. Lukas, thank you so much for your time this morning.
Thank you.